Anderson. In this video, we'll review externalities and deadweight loss.
Externalities are effects felt beyond or external to those causing them. Negative externalities are caused by things like pollution and bothersome noise, light, or smells. Externalities can also be positive. Sources of positive externalities include flowers planted by neighbors, nice smells wafting from a bakery, and education that allows people to make more contributions to society. I'm in Antarctica, where there aren't a lot of externalities, but there's also not a lot of production. There are always trade-offs. The production of goods we need and want typically creates negative externalities. Economic models help us identify appropriate production levels and establish policies that lead to those levels. Recall that for a perfectly competitive market, the market supply curve indicates the marginal cost to firms of making each unit. Here we'll call that marginal cost the marginal private cost to distinguish it from other types of marginal cost. For a good with a negative externality, we can measure the marginal external cost, which is the external cost per unit of the good causing the externality. Consider
lighting, which consumes about 7% of the electricity in the United States.
If electricity is generated using a process that pollutes, the marginal external cost adds to the marginal private cost paid by the firms that produce the energy. Society as a whole pays the marginal social cost, which is the sum of the marginal private cost and the marginal external cost. The existence of the marginal external cost places the marginal social cost above the supply curve. In the absence of negative externalities, the supply curve, the marginal private cost curve, and the marginal social cost curve are all the same curve.
For example, the electricity for these lights comes from those solar panels, so there's no marginal external cost to its generation. That means that a single curve represents the supply curve, the marginal private cost curve, and the marginal social cost curve.
Now let's look at benefits. The marginal social benefit is the benefit to society from each additional unit of the good. In the absence of positive externalities, the demand curve, the marginal private benefit curve, and the marginal social benefit curve are all the same curve. For a good with positive externalities, we can consider the marginal external benefit, which is the external benefit per unit of the good. For instance, each year of education for a student gives society the benefits of added productivity that serves consumers and firms, and shared wisdom. The marginal external benefit of that education raises the marginal social benefit of each year of education above the marginal private benefit. We find the best quantity for society, known as the socially optimal quantity, where the marginal social benefit curve and the marginal social cost curve intersect. Each unit beyond that quantity costs society more than the additional benefit it provides, and to stop production before that quantity would be to miss opportunities for net gains. In the absence of all externalities and other sources of market failure, the supply and demand curves are equivalent to the marginal social cost and the marginal social benefit curves, and the market equilibrium quantity equals the socially optimal quantity. The existence of externalities leads to an equilibrium quantity that differs from the socially optimal quantity. The result is deadweight loss. In the case of negative externalities, the market equilibrium quantity is higher than the socially optimal quantity, and the deadweight loss comes from the net loss from units that are produced at a marginal social cost that exceeds their marginal social benefit. In the case of a positive externality, the deadweight loss is the value of foregone opportunities for net gains. The deadweight loss triangle is found above the marginal social cost curve and below the marginal social benefit curve, between the market equilibrium quantity and the socially optimal quantity. To eliminate the deadweight loss from a negative externality and achieve the socially optimal quantity, the government could impose a Pigouvian tax, which is a tax equal to the marginal external cost. That would cause decision makers to internalize the cost of their decisions and make the best decision for society. Another option is for the government to limit the quantity to the socially optimal quantity, just as the government limits hunting and fishing in some cases. Likewise, a Pigouvian subsidy equal to the marginal external benefit would eliminate the deadweight loss from a positive externality. The government could also require the socially optimal quantity of the good, just as the government requires vaccinations and education. Notice that the deadweight loss triangle is like an arrowhead pointing in the direction of the socially optimal quantity, whether there are positive externalities or negative externalities. So if you've drawn a deadweight loss triangle and it doesn't point toward the socially optimal quantity, you'll want to rethink your artwork. Many of our decisions affect other people, which forces trade-offs between private decisions and what's best for society. By producing the socially optimal quantity of goods, the economy balances these interests in a way that maximizes its net gains. Even here in Antarctica, the continent has lost 3 trillion tons of ice since 1992, and externalities are involved. Hopefully, sound economic policy will help to protect life here and everywhere.